Welcome to the webinar of circuit simulation and PCB designing. So I will introduce myself. My name is Niraj Kapase. I have done my master's from University of Surrey in the field of mobile and satellite communication. Currently working as assistant professor in DKT's Textile Engineering Institute, Rajwada, Ichalkaranji. So in this webinar, we are going to see circuit simulation and PCB designing. So I will elaborate different tools of circuit simulation and PCB designing. Okay, so agenda of this webinar. So we'll start with basic introduction to the simulation softwares. So what are the different simulation softwares we have, basic intro of those particular softwares, list of different simulation tools available for the electronics. So many open source and paid tools are there, so I will elaborate those particular tools, features of some softwares. So what are the advantage and pros and cons of those particular softwares I'm going to explain in this webinar. Protease 8.9 features and overview. So in this webinar particularly we focuses on Protease 8.9. so this is a Protease software. It is a very good software for the simulation as well as it's very good for PCB designing as well. So we focus it on this particular software at Protease 8.9. So then next to that I will explain how to download and installation steps of the Protease. Then getting started with the Protease. So what are the steps we need to follow for designing a circuit in the Protease and in elaborating the circuit in the Protease. Then we see basic discrete electronic simulation, circuit simulation, enabling the analysis part of the circuit. So how you can analyze the circuit, how you can do animation of that particular circuit and all that we are going to see. Then again this webinar is divided into some parts, like we will see analog circuit simulation. So we'll use some analog components and we'll do a simulation of those particular circuits. Digital circuit simulation, logic circuit computational and sequential circuits. So we'll see logic circuitry as well, like basic gate, universal gates and so on. Then graph based simulation. So we'll do some analysis based on a graph, like low pass filter, high pass filter, band pass filter, and these many circuits we'll see. Then some IC based simulation, that is integrated circuit based simulations. Programming based simulation. So we are going to see how you can interface the programming, how you can interface different software tools like Python, C programming, CPP, embedded C in this particular simulation tool. Then how to add missing component library to the Protease, how we can add those particular libraries into the Protease, where to download the libraries, how we'll get library files, what is the file extension, we'll see that in detail. Use of different virtual instruments. So how we can use different virtual instrument like DSO, 4-channel DSO. We'll have function generator, we have digital oscilloscope, then we'll have analyzer, logic analyzer, voltmeter, all the virtual instruments we are going to see in this particular thing. Then animation based simulation. So how we can animate these particular simulations. So these are the particular things we focuses on. Next thing, virtual blocks coding. So there is new facility available in Protease 8.9, that is virtual block coding, where I'm going to elaborate that particular thing, like virtual block coding, how you can code by using virtual blocks. Internet of Things simulation. So there is another very good facility they have provided, that we can simulate IoT using the simulation tool. So we'll see that. Generating circuit schematics, how we can generate schematic, how we can save those particular schematic. Then PCB layout drawing, how we can draw this PCB layout. Auto routing configuration, manual routing. So we can do in both the ways, like auto routing and manual routing. So we'll see that how we can do auto routing, how we can do manual routing and all. Design rule change and management control, how we can decide some design rules for generating an PCB, what are the rules, how to follow those particular rules I'm going to explain. Component creation and package assignment. So how we can select the component and how we can create the component and how we can assign the package for that particular component. Next part is very important, like 3D visualization. So after mounting all the components, how your PCB looks like or how your circuit looks like, then we'll see a 3D visualization. Next is Gerber file creation and Epsilon generation. This is for CNC machines required. Gerber file is required. So we'll see how we can manufacture or how we can produce a Gerber file and what are the different extensions of Gerber file, what is present inside that particular Gerber file, we'll see in practically. Tips and homemade PCB. Tips for homemade PCB. So if you don't want to use a CNC machine type of a PCB design, you can do small PCB for your project purpose at your home only. So I will give you steps for that as well. Okay, we'll start now with the session. So this is about introduction to the session. What are the things I'm going to cover? Very first thing is electronic simulation or PCB design softwares. So we'll see a list of softwares. So I will elaborate more than 20-25 softwares in this. So depending on your requirement, you can choose any of the software. If you are mastering one software, then you can easily hands-on in another software as well. So like once you know how one software is used, and then you can easily transfer to the another software as well. So very first software is Ngspice. It is one of the popular and widely used free open source software, and it is open source, it is a free of charge. So you'll get this software from Ngspice sourceforge.net. So Ngspice is an open source software tool. So I will show you how to download this particular thing. So I will pause this simulation. I will open this, type on a Google Ngspice. Once you type on a Google Ngspice, go to this, here it is Ngspice simulator intro. So just click on that. Here at the home, you will get the basic information. So this is the schematic. We'll have Ngspice. Here it is the things. Here is the graph available. Okay, then there are the news, screenshots are available. So you can look at the screenshots. So we'll get list of different screenshots available. Then you can download it here. So these are the screenshots. So we can simulate the graph based simulation. Here it is like a rectified output or something like that. So we'll have some MOSFET based designs, and then it's the output. So here's the circuit and here it is the output. Also for the downloading option, so here it is a download. So there is a button known as a download. So once I hit on a download option, here you will get a downloading option. So we can have here, we can click on this particular thing. So we'll get a latest release directed. So we'll have both 32-bit and 64-bit setup available, and the setup is very small in size, like just 6.1 MB. You can download it from here. So website name is soundforge.net/project/ngspice. So you can download this particular software. Okay. All right. Okay. So this is about Ngspice. The second software I'm going to elaborate is GNU Cap. Again, GNU Cap is another open source software. It is developed as general purpose circuit simulator. So it's a general purpose circuit simulator known widely as a GNU, that is global GNU circuit analysis package. This is Linux based software simulator platforms. Various circuit analysis functions as DC and transient analysis and AC analysis we can do. So GNU Cap is very popular software, and this is basically used on a Linux based platform. So where to download this particular GNU Cap? So there is a website known as gnu.org. So we'll see that website as well. So I will elaborate all the websites, and then we'll see in detail analysis of those particular software and what is present inside that. So here it is, gnucap.org. So we'll Google it. GNU Cap. Okay, gnu.org, you will get there only. So they have different softwares available with gnu.org. So here it is GNU Cap. So you will get a download options here, free download EDA foundation, open collector and all. So you'll get download option here, and this is basically a Spice compatible model for MOSFET, BJT and diodes, and includes in this release. So GNU Cap is not based on Spice, but some of the models have been derived from Berkeley models. Okay, so features of new 0.35 version, that is nested subcircuits, named nodes are there, then parameters, like different parameters we can change. MOS level 8 to 49 models are there. DC sweep analysis we can do with this. Then improvement in transient analysis step control algorithms, improvement in switch model, focusing on timing accuracy and convergence, and C++ language standard corrections. So it is complies with GCC 4.1. So this is the latest version is 0.35. We can use it. Okay. So second software is GNU Cap. Then third software is Easy EDA. Third software is Easy EDA. So EasyEDA is another free software that doesn't require any downloading option. You can just sign up the software and you can do everything on the software page itself. It's a Chrome-based software. It's a web-based software, browser-based software. Then we can sign up and download an offline version as well, and it is free of charge. And also another very good facility of this is we can order the PCBs from this as well. So once you design your circuit, you can order a PCBs, and they will provide you minimum quantities of PCBs as well. So like if you require one PCB, then they will provide, no problem. Only the shipment charge is little bit higher, but you'll get it. And the PCBs are very good, up to 16 layer PCBs they support. So for this, again, Google EasyEDA. Just type on easy on a Google, just type EasyEDA, so we'll get this online PCB designer and circuit simulator. So this EasyEDA is generally commonly used for PCB designing, and it's very powerful tool for PCB designing. So you can look at the count. So many engineers are using this particular software tool, and here it is download offline version available. More than 1 billion free libraries are there. So integrated LCSC components are categorized. So we'll use like these components as well. So we can do a schematic capture, PCB designing, library design, project management, and team collaboration. So there is very good facility that we can collaborate the team as well. So like we have different themes and everything. So like we can have schematic theme. So if I run this particular video, here it is schematic. So we'll have different options like this. We can drag and drop the facilities just like this. So register is dragged and drop. You can zoom and zoom out. You can put the register in between the circuit. So it's very good option available. So we can have different colors as well, like black, white, and different themes as well. So you can set the themes and you can design a circuit. So EasyEDA is very powerful tool. Also there is a 3D view option available. So we can view after manufacturing the PCB. You can view the 3D visualization. So everything is on a Chrome based version, like it's a browser based version. So no different software needs to be installed. The thing is only we require a browser. That's it. Here it is, the 3D visualization. There is an option that 3D visualization. So it will open. So you'll get a 3D visualization like this. Okay, you can rotate your PCB. You can see the drill points. You can change the color of the back, green shading or blue if you require. So again, while ordering this particular thing, you can choose the color and you can order it. So it's an online order. So it's very powerful websites that it provides. It's very good thing. Okay, so here it is. What are the different layers it's having and all the things. Okay, so this is about EasyEDA. Next is Circuit Logics. So Circuit Logic, this is a student version software from Circuit Logics, enables you to perform analog, digital, and mixed mode circuits analysis. It is a Spice simulation software. It provides up to 4,000 devices on its student version, which is 1/3 of its pro version. The pro version is very huge, component list is available, but for the student version, they provide 4,000 devices. This circuit building software gives access to the switches, linear ICs, and digital ICs, FETs, transistors are there, relays are there, displays, signal generator, SCRs, optoisolators, photodiodes, semiconductors, motors, etc. are available in a Circuit Logics. So we'll have a website for this as circuitlogics.com/student version. We'll get the Circuit Logic software. So I will Google it again, Circuit Logics. So once I put a Circuit Logics, we'll get to directly go to a student version. So here it is, a home version is available. So pro version is paid version and the student version is a free of charge. So here it is a look of the Circuit Logics, and we can download it here from here. So here it is a download option. Download Circuit Logics for the student version by clicking here. So you need to click here to download this particular student version of the Circuit Logics. Okay. Next is Ltspice. Fifth software is Ltspice. Ltspice is a free circuit simulation tool from a Linear Technology Corporation. Again, earlier this tool was a paid tool, but after that they made it as a free. This simulation software is considered as one of the best freeware available. Highlights of Ltspice is much fast simulation of a switching regulator and enhanced spice. A high disadvantage of Ltspice is a proprietary code base which is licensed by Linear Technology. So earlier the Linear Technology has owning this particular software tool and they are selling that, but afterwards they made it for a free, but everything they tracks whichever circuit you are designing, that will be tracked by the Ltspice. So again, currently the LT, that is Linear Technology Corporation, is also known as an analog devices or analog semiconductors. So you'll get this on from their website itself. So just Google it, Ltspice. So once you Google the Ltspice, so very first link is Ltspice Design Center. Open this particular thing. Here it is a symbol of Ltspice. Okay, Ltspice is a high performance spice simulation tool, schematic capture and waveform viewer with enhanced and model for easing the simulation of analog circuits. Okay, this is a look of Ltspice, and then we can have different download versions available for Windows 7, 8 and 10. So we can download it here, this version. So its latest update is 3rd June of 2020, and the Mac version is available here. For the XP users, it has the previous older version, we can download it from here. So there are different categories of the software tools available. So like we have amplifier and linear, clock and timing, data converter, Ltspice, power management, RF and synthesis. So there are different softwares available from the analog devices as well. So you can download the Ltspice from here. So currently this webinar focuses on Protease. So I will elaborating Protease only, but in future webinars I am going to show you or demonstrate different tools. So it's not possible to cover all the tools in one webinar. That's why I'm just elaborating one software tool. But in future webinars, I'm going to elaborate these particular tools. Okay, so this is about Ltspice. Next is Multisim. Again, Multisim is very popular tool and it is designed and developed by National Instruments. So as you know, the LabVIEW, they are having very popular tool known as an LabVIEW. So the same Multispice is also designed and developed by National Instruments. Student version circuit simulation software from National Instruments. As you know, the student version always comes with limited access, so it's a limited access it's having. Still, this is a great simulation tool for the beginners in the electronics. So for the beginners to understand how the electronic circuitry works, this is again a great tool. Highlight features like it explores breadboard or 3D breadboard in 3D before lab assignment submission. Created printed circuit boards, etc. Breadboard simulation is possible with a Multisim circuit simulator. So Multisim is very popular tool, and the breadboard is available in the Multisim software. So I will show you the Multisim, and it is a software by National Instruments. So just type Multisim. Just note down all the software tools. So if you require, you can download it and you can test it afterwards. Here it is Multisim live. So we can have just sign up for this and then we can download this particular view. So there are different simulations also available, feature circuits. We can do a lot many things with this. Create circuits and simulate with the power of a spice. Learn feature contents and community circuitry. Collaborate with the lesson, homeworks and project design. We can do with this single particular site. So again, Multisim is very popular thing. Okay. Okay, Multisim is done. Now next we'll move towards Topspice. So Topspice is designed by Penzar, and this is a demo version circuit simulator from Penzar. And the Topspice is mixed mode mixed signal processing, and its analog behavioral simulation model is also possible. So there is a website known as penzar.com, Topspice. So I'll copy this particular thing and then I will put it on directly here, so that we'll come to know that this Topspice simulation. So it again supports with Windows XP 7 and 8 and 10. Okay, so we can download a free demo here. So it's a paid software, but we can download a free demo here. We have a product highlights like this. So there are integrated design environment, capture schematic, simulation, waveform plotting, post processor, and everything is available here. So like this graphs are Smith trigger graphs will be done with this particular thing. So there are some advanced features. So we'll have a graph based simulations and all. We can have circuits here like this. Okay, we can do a DC bias point, DC sweep, tangent analysis, AC sweep, temperature cycle, parametric cycle. Then we can do Monte Carlo, worst case, then dot altered, post processor directives. So we can do this, and then there are the opt-in simulation output settings as well. Okay, so this is again nice tool, but the demo version is available, so you can use it. Next is SimScale. The SimScale is a cloud-based simulation platform, which we can do everything online. So again, it is a online software-based or browser-based tool. They have a free community plan, which you can sign up, but all the circuit you make will be publicly available. So again, the limitation is whatever you are doing, your research will be publicly available. So again, their website is simscales.com. So you can use simscale.com for writing your circuitry or creating your circuitry. Again, SimScale is a browser-based tool. I'm just opening this particular tool. Here it is. It is a simulation tool reinvented for on the web. So start simulating for free. Just you have to accept the cookies and then start simulation. So it supports many of the case studies as well. So there are many their partners and all. So here it is. It supports CADs as well, Autodesk 360 as well, and it's a very good tool for online design and online circuit simulations. Okay, so we'll have like community version is a free for education and hobby project, up to 3000 core hours and up to 16 cloud counting cores will be used. But if you buy a professional version, it's a single account with a commercial project, all community features, private projects, live support. When you buy it as a professional version, then it's a private project, but rest of the thing, if you're using for a free version, it's a private projects are not available, so it's a public. So whatever you are doing, that can be accessed by any version. So there is again a team version is available, and also enterprise version is also available, so you can look at this afterwards. So SimScale is again a good tool. Next is PEX. PEX is particularly a power electronic circuit simulator. So PEX PECS is a power electronic circuit simulator. Is a free power electronic circuit simulator created by Richard Tamersky. So Richard Tamersky is he's having his own project, and during that project version he has published this particular thing. You will not get directly this thing on a Google, so you have to note down this particular website, like the http://web.ccs.pdx.edu/ty Messeriki. So I will copy this and I will just paste it here. Okay, so he's having a different courses available, so you can have a download PECS here. From here we can download this, and he's having very courses as well, so you can view his courses, we can access his courses as well. So during his project he has developed this particular tool, and but the power electronic simulation, this is very popular tool. Okay, next is QUCS, that is Quite Universal Circuit Simulator. So Quite Universal Circuit Simulator is a free simulation software tool developed on GNU or Linux environment. Well, this software really works on other operating systems as well, such as Solaris, Apple Macintosh, Microsoft Windows, FreeBSDs or NetBSDs. So this is available. It is developed in Linux environment, but it works on different platforms as well. This basically it uses Qt for developing this particular softwares. Users can simulate large signals, small signals, and noise behaviors of the circuit using a simple circuit emulator. So we can see this particular thing as well. QUCS. So you'll on the SoundForge, you will get this particular website link. You can download it from here, and it's open source. So current release is 0.019. You can download. Go to a download link. Sorry. Go to a download link. The latest version is available. You can download it here. Okay. So we can have different versions. Like this is link for Ubuntu, this link for Mac, and this link for Windows. So it supports Windows 32-bit or also 64-bit. Okay, so we can use it. So official packages are also available, so we can download different packages. So for Debian, FreeBSD, Fedora, SUSE, so these packages are also available like Arch Linux. So you can download these particular packages as well. So current version is 0.018. Okay, so this is about QUCS. Next is Solvilec. It is an electrical circuit simulator software. It's a free version which is developed by Macintosh OS and Windows. It enables users to draw and analyze the circuit, both electrical and electronic function in direct current and alternating current facilities. So there is a website known as physicsbox.com. So on this website you will get Solvilec. So this is generally for solving the electronic circuitry or solving the electronic problem. This particular software is been used. So I'll open this and I will show you. Solvilec is generally used in Mac and Windows version. So we'll have a demo version available here. We can download it here. So current version is Elect 2.5 and it is a 32-bit also version. It works on 64-bit PC as well. So we'll have a circuit examples here. So new version supports analysis of circuits in AC, oscilloscope, filter analysis, formulas and values of transfer function. So basically it is for electrical control systems. So we can analyze some circuitry with their transfer functions as well. So frequency response graphs and all. So these things are possible in this Solvilec. Next is Pspice or Pspice or OrCAD. Again, this is very popular tool, but it is a paid tool. It is a mixed signal or industry standard circuit simulator. So many of the industries are using this OrCAD tool, and it is designed by Cadence. This software is used by many professionals in electronic system design and development. OrCAD, the printed circuit board design software, is developed by same company known as Cadence. So there is a website orcad.com. So we have to open this orcad.com. So we can download the version of trial version of an OrCAD from this orcad.com. But this version is a paid version, but it's very popular in the industry and it's having very sophisticated design of the PCB. But for designing of the PCB, this software is very good, but for simulation or just for understanding the circuit analysis, this software is not that much good. Okay, so for designing it's very nice. Okay, so we can try for free. You can download it from here for the free of charge. So it's having Capture, Pspice Designer, PCB Designer, PCBSI, Engineering Data Management, Library Builder, Product Document Editor. So these things are optional. So these are available. Okay, so you can download it from here. The free trial, we can get it from here. So we need to register online, register with your email ID and everything. So we'll get a free trial. Okay, so this is about the OrCAD. Next is Tina. So Tina software is again it is affordable, cost-effective circuit design and simulation software. It very popular in the feature and functions. You can buy the basic version of Tina design suite 9.3 as low as 90 euros, and the classic version suited for the professional engineer is available from 600 euros. So basic version is 990 euros only. So we can get it from tina.com. Again, the tina.com is the website. You will get the Tina software from tina.com. So here's the option. We can open this tina.com. It's a circuit simulation for analog and mixed version. You can get a full version or we can have a demo version as well. So we can do analysis, powerful and affordable software. Then we'll have mixed SDL analysis. Then we can have SMPS, microcontroller based simulations. Then we can have flexible licensing options, integrated PCB design. We can do this. With this, we can have Tina cloud interface. We can do everything on synced with the cloud as well. So this is online cloud simulation platform and offline cloud simulation platform. So these things are possible. Okay. So again, microcontroller MCU selections are also available in this Tina. Okay. So Tina is again a popular tool in the industry as well. Okay. They have their own cloud as well. So you can design the circuitry and you can have upload on the cloud itself, and you can work from any point of the world through a cloud. So this is about Tina. Next is PowerSim. Again, this is basically for power electronic circuit simulation. for motor control, motor applications, and requirements like dynamic system simulation. So we can get the power sim from powersimtech.com. So I can open the powersimtech.com. So there is a website known as powersimtech.com. On this website you will get a power sim simulator. So it's an electronic simulator for simulation of motors and everything. So it's basically a electrical based, more is a power circuitry or power electronic circuitry we can simulate through this power sim. Okay, so fastest simulation in the world. Okay, so like there are different facilities available, so you can download or we can try it from here. Try BSIM today. So once you try, you're going to put all the credentials, then we'll get download a free demo, and you can test and try this particular software. Next is MicroCap. MicroCap is analog and digital circuit simulator with an integrated schematic editor that provides an interactive sketch and simulate environment for electronic engineers. It is developed by Spectrum Software and it is currently at version 12. The Spectrum Software Business Cloud down, and MicroCap is released as a freeware. So as the Ltspice has been released as a freeware, same MicroCap is also released as a freeware as their business gets down. So you can download the MicroCap from this particular website, that's spectrumsoft.com. So I will open the spectrumsoft.com/index. So here it is, Spectrum Software. So we'll have, so it's a company established in 1980s. Then we can go to a download section. Under a download section, the MicroCap 12 version is available, so you can download directly. So it's a 58 MB software, full CD, and executable will have 16 MB. So again, user guide is available, reference guide is available, and browser is also available. So its release date is 18/11/2019. So last year it's released, so we can use this particular tool, and they made it is freeware after this. Okay, after 2019 they made it free. Earlier they have the paid versions. Next is Organo. Organo is a graphical software application for schematic capture and simulation of electrical circuit. It is a Linux-based software. It's a freeware. So we'll get Organo from GitHub. GitHub is a repository for different softwares. So there is a github.com/hnr/organo. So I will show you the Organo. Copied and pasted it. So you can type Organo on Google. You will get the same link as well, or note down this particular link. So github.com/drahnr/organo. So you can download it here. So this is a Linux based platform, so it works on a Linux, so it will not work on Windows. Okay, so there are different whatever the codes are required to install this particular software on Linux, that are mentioned. Next is Zenith PCB. Zenith PCB, there are two software packs. One is Zenith Capture, which is for schematic drawing, and second is Zenith PCB, which is for PCB layouting. So we'll have, there is a website known as Zenith PCB. Again, this software is very popular. So many of the circuits you look at in EFI and all, so that will be drawn through a Zenith PCB. So again, this is very popular software tool, and the drawing and everything is very possible. So you can download the version here from the download button. So there are two versions. One is Zenith Capture and second is Zenith Suite. Once you download Zenith Suite, you will get two versions like Zenith Capture and Zenith PCB. Both things are there. Okay. Next is again a popular tool like DipTrace. DipTrace is again industrial tool, and DipTrace is licensed software, 300 pins design for a free year for a lifetime. Again, it is licensed software, but once you install the freeware from the website, you'll get 300 pins design tool for a free of charge. Both schematic drawing and PCB designing is possible in DipTrace. It supports 3D modeling as well, and there is a website known as diptrace.com. So I will show you their website, diptrace.com. Here you go, diptrace.com, the schematic and PCB designing software tool. then go to a downloads to get download the version. The freeware version supports up to 300 PCB drill points or 300 components. Then we can have featured version as well. So it's having very good look. So we can do a 3D modeling as well in the deep press. It's very popular. So we'll get support as well, and it's having very good community support as well. Next is Eagle. Eagle is again Cadence tool, again designed by Cadence software. Eagle is an electronic design automation, that is EDA software, enabling printed circuit boards designers to seamlessly connect schematic diagrams, component placement, PCB routing, and comprehensive library content. So this is designed by Autodesk. So again, this is a very popular tool. So we'll have next workshop on Eagle as well. So again, industry is using Eagle. Why? Because Eagle is having more freeware. So like 600 DP, we can have free licensing for Eagle, and we can have a 3D visualization and everything like 360-degree PCB view. Then we can have multi-layer PCBs and all. So it's very popular, and industry is using this particular tool. So we'll have second workshop on this Eagle as well. Okay, so so we can have very good thing. So the Fusion, if you buy, is the 22,420 rupees per year. So once I watch this Eagle video, so you look at this. So this is a Eagle schematic. So we can have USB hosting. So multi-layer versions are also available. So labeling is easy. So wire labeling is there. So just click on the label and just giving the labels. Here it is like this. So very good software tool. Okay. Next is OSCAD. Again, OSCAD is designed by IIT, and OSCAD is again also currently known as an eSIM software. Previously, it is an OSCAD. It's a free EDA tool. It's a free and open source tool. We can design, simulate, and analysis, and PCB designing is also possible. The integrated, it is an integrated tool built using a free or library and open source software. So the IIT has initiated FOSSI community. In that FOSSI community, they have designed and deployed this particular tool. So free open source software for electronics engineering. So esim.fossi.in. So once you open on a fossi.in, we'll get different software tools available as well. So, sorry. Yes, it's connected. Wait, I will Google it directly. Type eSIM OSCAD. So we'll go to home. I think the site has been down. So we can get the software from FOSSI itself. So the site looks like this. Okay, eSIM, we can have download version here. We can have forum, fellowship, testimonials. Many softwares are available on FOSSI. So you can open a fossi.in. So there is a Scilab also available on a FOSSI. So this is Scilab is again very parallel software with a MATLAB as well. So that is also available on a FOSSI itself. Okay, so again, this is hosted by IIT Bombay. Okay, so this is the FOSSI tool. It's very good tool again. The next is Protease tool. So in this particular webinar, we are focusing on Protease tool. So Protease is a Pspice mixed mode spice based simulation tool from Lab Center. They have two versions, basic and advanced version. The basic version is a free, which supports interactive simulations only, while advanced support a full range of useful functions and features like graph based analysis, which includes frequency, noise, distortion for your parameters, etc. So we can have their website known as labcenter.com. So we'll get this particular tool, labcenter.com. So once I type labcenter.com, we'll get a Protease tool. It's very powerful tool, and it's very good tool for simulation. So we'll have PCB layouting, we have circuit simulation, we have IoT builder as well, integrated all the things together. So there are two versions. One is Protease for industry, Protease for education. So we can download the Protease for education directly. So in case of industry, it supports virtual prototyping, enables system testing before the first physical PCB ordered, shape-based auto routing, and standard save time with non-critical routing. Direct access to 15 million parts means so never building a component and a footprint again. So we can have circuit simulation gives student fast and fun practical learning tool. A software solution allows instructor to prepare and reuse the virtual labs. Flexible licensing gives freedom for the classes and assignments. So it's very good tool. So we can have different libraries. We can have high-speed design, DRCs, design rule check. We have debugging. We have VSM. Then we have IoT. So all features are there. Okay, you can download the demo version of a Protease from here. So go to a downloads button. Here it is, download the demonstration version here. So we can download the version, you can install it, we can run it. There are 3 limitations only for the download. You can only print the schematics and layout from your sample design. You cannot save your work. So this is big disadvantages of demo version. You cannot simulate your own microcontroller design. So this is again a limitation, but you can try the download. It's very good tool. So I will elaborate the Protease software information. It's a PCB designing tool, circuit simulation software for a modern EDA developments. Good interactive simulations we can do. Animation based simulations are possible with the Protease. Virtual prototyping that enables the system testing before the first physical PCB has been ordered. We can do auto routing as well as manual routing. Then where to download the Protease? So current version of Protease is Protease 8.9 version. So Protease 8.9 is an interim release introduced in March 2019. Main features: built-in libraries for parts and components, enhanced the Gerber editor, web search panelization, autocomplete the manual route with the enter key. So we'll see what is that autocomplete with the enter key. We'll see while demonstrating this particular thing. So downloading steps: you can download the demo version from Lab Center, then click on a download here. So here it is a button, download. So you can click on that download button and then download it. Then limitations of demo version. So we cannot, as I explained earlier, we cannot save your work. You cannot simulate the microcontroller based design, but you can do the rest of the things. Okay, so I have downloaded it. How to install it? So just after downloading, just double click on that. Very first window you'll get like this. Okay. So I'll maximize this and so that is more. I have already installed it. So for this you'll get like this first window. Then we need to click on a next button. Okay. Next we need to accept the license agreement here. Click on accept agreement. Again click on the next button. Then use locally installed license key. You have to select this. Click on next button. Then select this particular 3 options, that is merge styles with the previous version. If you are using previous version of a Protease, then you can import directly those particular styles and your components in the Protease 8.9 version directly. So for importing this, you need to tick all these options: merge styles and versions, import templates and previous versions, import user libraries from the previous version. Tick this. Click on next again. Then there are 2 options. One is a custom and typical. Select the typical option, and the installation progress will looks like this. Then these are the previous legacy parameters. Like I have installed Protease 7 as well, so it's showing me this libraries are you installed. So I need to import this. Click on import. Once you have imported, you'll get like this window. The Protease 8 Professional has been successfully installed. Run the Protease 8 Sim Professional. Okay, so we can run it and we'll test it now. Okay, I will just minimize this particular thing. Okay. All right. So those who have not subscribed my channel, you can subscribe my channel for next upcoming updates. So how to subscribe it? Just go to youtube.com, then type, or you're already on this particular channel. So within a video, there is a subscribe button here. So we need to do that particular click the subscribe. So currently I'm admin, so I'm getting all the access like analytics and edit video, but you can click it here, subscribe. Okay. Alright, we'll see a demo of the Protease now. Here it is, Protease set. I will open it. The symbol of Protease set is Protease set professional. So it is CAD connected. It loads it. So current version is 8.9 I have installed. So first look, here looks like this. So here we have schematic capture, here we have PCB layout, simulation, migration guide, help options, about the licenses, then evaluation version Protease Tool. So I am using evaluation version. Then we can download 8.10 as well. SP0 is a beta release they have released 18/05/2020. Just now they have released it. So if you need, you can download it here. Okay. So under a file we have new project, open sample project, import legacy projects, import ECAD library, save project as, close, explore, and everything. Okay. Under the system we have system settings, check the library updates, repair the language packs and all. Under a help we have overview about the Protease. It is again designed in a Qt, so about Qt and Protease help. Okay. So so easy way to open a new project is just hit here. So these are the different shortcuts available. So first shortcut is a new project, second is open project, third is save project, fourth is close project. So home project, home page is there, home page is this page. Then next is the tabs. So click on a schematic capture tab. So once you hit on the schematic capture tab, the new tab will open here. So look. Okay, the new tab is available. Now we'll have a schematic capture tab. So under this we have different options. So here this blue border is there, blue square. This is your schematic drawing area. So you can zoom in and zoom out using your mouse. Scroll up your mouse to zoom in and zoom out. So this is origin point, center point. So you can move your scrolling of a mouse to zoom in the grid and zoom out the grid. Okay. And if suppose if you have zoomed out and if you need to get full screen window, then just press F8 button to get full screen window. Okay, this is the shortcut. So I will explain you different options here. What are the different options available with this particular Protease? So here under a file we have new project, open sample project, open legacy project, then save project, close project, import an image, import and project clip. Then we have export graphics, so you can save in different formats. We can have printer setup available here. We can have exit applications. Okay. In the edit option we have find the component. The shortcut is E button. Select all, cut, copy, paste, send it back, send it front, tidy design. We can highlight the design and everything. Under a view tab we have a redraw grid. So this is a grid. We can redraw it, toggle the grid, toggle the false origin. So this is origin as I told. We can toggle it again. We can toggle X cursor. Okay. Then we can have a snips like 10th, 50th, 0.1, 0.5 and all. Origin at a cursor. So this is origin. Zoom in, zoom out. Either F6, F7. F8 is to entire sheet. Zoom area and toolbar configuration. Under the tools we have wire auto router with a W. Search and tag the components. Property assignment tool with a global annotator. ASCII data import. Electrical rule check. In the ASCII data importer we can have different builds, product builds and everything, component builds and everything. Netlist compiler and model compiler. So these are used for PCB designing. We'll explore you afterwards. Under a design we have here a design sheet properties, edit sheet properties, edit design, configure new rails, new route, remove, go to previous or sub sheets we can create. So this is a main sheet. We can create multiple sheets as well. So here you will get a root sheet 1, root sheet 2, root sheet 3. If your circuit is too big, you can do that. So here you can add the sheets. So here only one sheet is there. We can have multiple sheets as well. And same you can these sheets are interlinked. So once you create on a PCB design, so all the sheets are combined and then the PCB has been created or generated. Under a graph, we have edit graph, verify the graphs, verify files. We'll see the while simulating the graph, what are these options are there. Under debug, we can start and stop, pause, run simulation. So these things are available here. Under library, we can pick a part, import the component, compile to a library. So these things are available here. Template, we can set different styles, graphic styles and everything under a template. Under a system, we can set a system settings, text viewer, display options, set keyboard mapping and everything. So we can change shortcuts through this keyboard mapping and all. Then set animation options, simulation options are there, restore default settings, and under a help, we have help options. Okay. So this is the thing we have here. The same shortcuts are available here. So very first shortcut is selection mode. So while choosing any of the component, we need to go to a selection mode every time. This second is component mode. Third is junction dot mode. Like when there are two dots and these two lines are connected, then we need to use this junction dot mode. Third is a label. Fourth is discrete mode. Fifth is burst mode. Suppose there are 8 lines traveling and we need to attach those 8 lines. We can see that by using this burst mode. Next is subcircuit mode. We'll see this as well. Then terminal mode, we'll have input, output, bidirectional, power, ground, chassis, dynamic, bus, and I see these things are there. Under device pin mode, again input, output, peak lock, short, bus, default pins are there. To create a component, this device pin mode is used. Graph mode, we'll have a digital graph mode like analog, digital, mix, frequency, transfer, noise, distortion, Fourier, audio, interactive, conference, DC sweep, AC sweep. Like these graphs we can create within using a graph mode. Next is active pop-up options. Generator mode, we have different supplies available here like DC, sine, pulse, exponential, SFM, then audio, D state, DH. We'll see while doing some circuits this thing. Then these are the probe mode. There are voltage, current and tape. Then we'll have oscilloscope, virtual instruments. We have oscilloscope, logic analyzer here. Then we have counter timer, we'll have virtual terminal, SPI debugger, I2C debugger, signal generator, pattern generator, voltmeter, DC emitter, AC voltmeter, AC wattmeter is also available. And these are the graphic tools available here. Okay. So these are the things at the corner side. So every time when you move the components, so you can zoom in and zoom out by using a scroll of your mouse, and you can draw within this particular blue area. If you want to come back full screen, press effect. Okay. So very first circuit, what we'll do is voltage divider circuit. For this, I will show you the circuit. We'll take 2 registers, just simple circuit, how to take components and all. So we'll see that. So I will choose this. Okay. So we'll take one battery. Okay. Then we'll take 2 registers. One register here, another register here. Okay. And I will make this as a ground. Okay. So this is my ground, G and D. So this is my R1. This is my R2. Suppose R1 is of 5K, R2 is of 10K, and battery is of suppose 12 volt. Okay. So the current will flow from positive to negative like this. Okay. So we are going to measure the voltage across R1. So this is my V1, and voltage across this is R2. This is my V2. Okay. So we'll see what is V1 and what is V2. Okay. So generally how we calculate? We'll calculate R equivalent is equals to, these are connected in series. So 5 plus 10, that is equals to 15K in series. So total resistance is 15K. We know the Ohm's law, V is equals to IR. So accordingly we calculate I is equals to V divided by R. So V we know, that is 12 divided by 15K. So whatever the I we are getting, So we just multiply this R with this particular I, we'll get the voltage between this resistance, and when we multiply with this particular R, we'll get voltage between this particular resistance. Okay, so we'll see the simulation now, how it actually works. So I'll come to Protease. So how to take components for this, click on selection mode, click on a parts, the new window will open. So here type your component, so type res. So once you type register res, so you'll get list of registers available. So we need to have device, general device, so select res, and we need to, here it is, the simulation like symbol is available, and the PCB preview. So I need not, this is a SMD component, I need local one, so I will choose res40. So this is non-SMD component, so I will choose OK. So one resistor has been selected. Now we require a battery, so I will type battery again by clicking on component, again click on part, type battery. So select battery, battery active DC voltage source. Okay, so this is a symbol. Battery is not a PCB component, so no PCB preview is there, so click OK after this. Alright, so those two components are done. Now I need to mount a circuit. So what I will do, I will click create a battery, I will put a battery here. I've done, enter the battery. Okay, you can zoom in. Now select the resistor. Now the resistor is horizontal one. If you want to make it vertical, plus symbol you can place, or you can fix it and then rotate. Plus is there to rotate. Okay, so I have rotated it, put the first resistance, put the second resistance. Okay, now I need to make the connections. So for connection, click on selection mode, go to selection mode, then just move your mouse over the battery, first battery terminal. So your mouse cursor will convert into a pen. So just click there, go up, this. Okay, done with one connection, do the second connection. Okay, it's connected now. Now we require a ground as well. So select, the ground is available in terminal mode. So here it is terminal mode, the ground is available. So you can put a ground or not, that doesn't matter, because already is a negative terminal. Okay, so I'll keep, because I brought in circuit connected. Okay, now we require to change the properties of R1. So as in my circuit, as I told, R1 is of 5K. Okay, so how to change the properties of that? So we'll see. So just double click on this particular resistance, the property window will open. Instead of resistance 10K, I will put 5K. Click OK. Once you've done that, the 5K will be up. So R2 I am not going to change, R2 is as it is. Now I need to attach a voltmeter. Okay, voltmeter, where we will get in this virtual instrument mode. So I will click on the virtual instrument mode, go to DC voltmeter, because this is a DC circuit analysis. So select DC voltmeter, I'll put here voltage, first voltmeter, I'll put the second voltmeter here. Okay, I will attach with the wire. Again this is attached and this is attached. Okay, so in this circuit, the current will flow from this terminal towards this, like this. Okay, and the electrons will flow from negative to positive. We'll see that. So this is the current direction, this is I. Okay, now we'll change the current, change the color, then the electrons will flow from this towards this. So this is the direction of electrons, E, negative to positive and then the positive to negative. Okay, are you clear with this? Now we'll see actually a working of this, simulation of this. Okay, So for the simulation, there is a run icon here. Okay, just need to hit the run icon. Once you hit the run icon, it will simulate the circuitry. It will display the 4-volt output here. Look at this. The 4-volt output is there across the R1, and the 8-volt output is there across R2. Okay, so this is the very good thing they have given, like we can simulate the circuit as it is, and also the thing is we can have current and voltage directions as well. So go for that. To observe this particular thing, go to system, go to set animation options. Here there are two options, like show wire voltage by color and show wire current with arrows. So tick these two options, click OK after this, and again run it. So you can observe the difference. So earlier these colors are not displayed, but currently these colors will display. So this is the current, the positive voltage is there. So current direction, as I drawn, this is the current direction. Okay, we'll get a voltage and all the things. So this is your first circuit. How you can save the circuit? Sorry. Okay, to save this particular circuit, we need to click on the save project button. So just once you hit the save project button, it asks you the name of the circuit where you want to save this. Okay, so I'll give the name as circuit 1, circuit CIR01. So simply will do. Okay, once you save it, that is saved with CIR01, you can simulate one more time if required, and you can zoom in, zoom out. Also you can pause it here, stop the simulation, go to system, set animation option, click wire voltage and color, again rerun it. You will get the running icon as it is. Okay, again you can stop animation. Okay, we can save this particular circuit. Alright, so this is about very first circuit diagram we have seen, voltage divider. Again, if you want to change or delete some component, just double right click on that, it will be removed. If you want to add it again, go to this option, select it, put it here. Okay, like this. And there are two options available here as a wire current and all. So if you want to measure the current, so here it is the current probe, just put a current probe here. Okay, I have marked the current probe here. Now we can run it. So you can observe the current value is I is equals to 0.0008, that is 8 milliampere, the current flowing from this circuit. Okay, we can have 5K multiplied by 0.008 is a 4 volt. Okay, so same thing we can do, like we can measure voltage as well, we can measure the current as well, and these are the markers available. Okay, now we'll see the second circuit, that is alternator response. This is first circuit is a DC circuit. For that we'll choose an alternator. Just type alternator. We'll have animated alternator available here. So we'll select that alternator. Okay, and just we select one lamp. Okay, just click on a lamp. So it is animated light bulb available. So we'll see that very basic circuitry, how the alternator works, how the positive and negative half cycles runs. So I'll select alternator here. I'll put a lamp here. Simple circuit. Okay, I will connect that with a wire. Again, go to selection mode, select a wire, draw like this. Selection mode, select the wire, draw like this. Okay, change the properties of this. This is here, it is a 12-volt bulb, so I need to put amplitude as suppose 12 volt, and I will keep the frequency as 1 Hz. So to observe this, I will keep frequency as low. Okay, so go to this, go to animation option, set wire voltage and color, click OK, and run it. So you can observe here is the positive half cycle, then again negative half cycle. Okay, you can change of cycles, so rate, and you can observe this particular thing. So here it is alternative circuit available. Okay, I'll stop this, I'll save this particular thing. Okay, so this is about alternative circuitry. We'll close it. Next we'll see the transformer response, like primary and secondary transformer circuit for the third. So we'll open a new schematic. We'll close this. I will close this as well. I'll go to reopen the Protease. Okay, click on a new circuit. Okay, click on the parts. We require transformer. For that we require type 2P2S, that is the keyword for transformer. It is a simple transformer we need to look. So this is a simple transformer. So either you can type trans dash 2P2S or we can type simple transformer in the keywords. So we'll select this simple transformer. So we'll have multiple transformers as well, like center tap is available. This is center tap transformer. Okay, so these things are also available, but we'll take a simple transformer. Click OK. We require alternator as well. So type alternator. Select the alternator. Click OK. Then we require lamp. So select lamp, animated light bulb. Okay. So what is the circuitry we create? We'll put alternator here. We'll see primary and secondary of the transformer, how it differs the things, and at the secondary side we'll put a lamp. Okay. Sorry, if you want to move it, click on that and just move it. Alright, so these two things are connected. So I'm going to connect it with the wire. Okay, done with the connection. Alright, so I will save this particular thing first. Okay, so what the thing I will do is I will put voltmeters. So here it is a AC circuitry, so I will put the AC voltmeter at the primary side and AC voltmeter at the secondary side. Okay, I will connect the AC voltmeters on the line. Alright, so I'll change the parameters of this particular alternator. Sorry, input voltage is suppose 1 volt, 1 hertz. Okay, change the transformer parameters. So here it is primary inductance 1 Henry. Suppose I need secondary inductance as 150 Henry, coupling factor as it is, primary DC resistance as it is, and secondary DC resistance as it is. I will click OK after this. Then I will go to system, set animation option, click on this. Okay, save this particular thing and run it. Now you can observe here the voltage will reach up to 1 volt only. Okay, but at the secondary side it reach up to 10 volt. That's why bulb is on. Okay, if I change the inductance, the bulb will not get turned on. If I change the inductance as it is, so primary is 1 Henry, secondary is also 1 Henry, and if I run it again, so you will not observe this particular thing, 1 volt only. Okay, so this is not good. So for that we need to change this inductance. It's 150 Henry. So this is a step up type of transformer. Primary is low voltage, secondary is high voltage. So it's a step up transformer. Now we'll do for step down transformer. So change the primary inductance is suppose 150 Henry, secondary is suppose 1 Henry, and primary voltage is suppose 230 volt. Okay, and if I run it, you can observe. So till 230 it will go, here it is 15 volt. So it's dropped down. Okay, so you can observe. I have kept 1 Henry, that's why 1 hertz, that's why it's very slow. But for the 50 hertz, it's very fast. Okay, are you clear with this circuit? Okay. Those who are not subscribed my channel, please subscribe my channel. Okay, so this is for today's session. Okay, so again tomorrow we'll see next circuitry at the same time. So please stay connected with me. Okay, so thank you for listening patiently. We'll end up the today's session. We'll see tomorrow again more circuitry, more advanced circuitry. Okay, stay connected, stay tuned tomorrow. Those who are not subscribed the channel, please subscribe. So in the description link I have given today's session feedback link. So click on that description bar, click on that particular link and fill the today's feedback. Okay, thank you for listening patiently. Thank you.